Today's lesson is on transformations of functions. And so I've written a formula here. F of x equals a times x minus h plus k. And all of your equations are not going to necessarily be in this form. They will all have the f of x and they will all have the x, but they may not have the a, the h, or the k. And so what I'm going to go through with you is what do a and x and k and h all mean, and then you'll know when you see an equation what kind of transformations take place. Again, you did this in Algebra 2, so it's probably a review for you, but I'm going to go ahead and start. A is always going to tell you whether your function has a stretch or a compression. Now, sometimes that compression is called a contraction. I've seen it written both ways. So either a compression or a contraction. I actually like to use the word contraction because it rhymes with the word fraction. And that's what it is. If a is a fraction, then the graph is being contracted, or the function is being contracted or compressed. If a is a value greater than 1, then it's stretching your graph. So if it is a value greater than 1, then it's going to be a stretch. And if it is a fraction, it's going to be a compression or a contraction. Okay, h tells you that you are going to move your function left or right. Think about it. H is inside parentheses with the variable x, and x runs left or right when we're talking about a graph. So h is going to tell you to move left or right, but it's going to be in the opposite direction of what the sign is in the equation. So you have to remember that if h is negative, then you're actually going to move right. If h is positive, you're going to move left. So I'm going to put that here also. If h is negative, then you're going to move right. If h is positive, you're going to move left. Okay, and then we're going to look at k. K is at the very end of your equation, and this goes along with the y values. So this is going to tell you to move up or down, and you're going to move exactly the way you see it in the equation. So if it's a plus, you're going to move up, and if it's a minus, you're going to move down. The last part of this lesson, we're actually going to write the function given the parent function and the transformations. So if we look at number 1, it is a quadratic. That means that when I write the function, it's going to have x to the second power. But before I write x to the second power, I need to see what's going on here. So we have a stretch by 2. Any stretch or compression is always going to be written first. It's going to be written in front of the x. So I'm going to go ahead and write 2. Now I also see that I have a left and a down movement. Any left or right movement is always going to be inside a set of parentheses with x. So x, and it's left 1. But remember, any left or right movement as the transformation becomes the opposite sign in the equation. So instead of -1, I'm going to put +1. And then I can put that 2, which makes this a quadratic on the outside of that parentheses. The last thing I need to write is the down 3. And there is the equation for the parent function with these transformations. The second example, the parent function is an absolute value function. So again, before I use the absolute value of x, I'm going to look and see what the transformations are, and I do in fact have a compression of 1/3. That's going to become the first thing that I write, and then I can write those absolute value bars. X is going to be inside the absolute value, and it looks like I have a right move of 5. Left or right goes with the x inside the absolute value bars, just like inside the x with the parentheses. And it says right 5, which means I'm going to make this the opposite sign, so that will be minus 5. Those are all the transformations, so I am finished with that equation. The last one, and I forgot to mention reflection when I was talking about the values of your A's and X's and H's and K's. So I'm going to flip back over to the notes here. When I told you about A, it's a stretch or a compression or a contraction, but A also tells you whether or not you have a reflection. So if A is negative, then you also have the transformation called reflection. And that's what we have in this third example. It is a cubic, that's the parent function. That means that x is going to be to the third power. But again, we have to look and see, is there anything that I need to write before I put x? And all I see is reflection. That means there's going to be a negative sign. But there is no stretch or no contraction. So I can go ahead and I can put x down. But before I put it to the third power, I need to see, okay, I have left 7. That means that there's a number that's going to go with x, which means I need to put that in parentheses. Okay, so left 7, okay, again, so that's going to become a positive 7 because we do the opposite sign. And now we can put that cube, that exponent of 3, behind the 7 on the outside of the parentheses, which makes it cubic. And then we can put down 8, so that's going to be minus 8. And there you go. That's your third example.